Okay, so we're working on 2-3. We're working with writing equations and specifically talking about parallel and perpendicular lines. So let's just kind of break down to the basics before we start writing equations. And let's make sure that you remember the definitions of parallel and perpendicular lines in terms of slope. And so if you have lines that are parallel, we know that the slopes will be the same. And remember, we use the variable m for slope. If they're perpendicular, we know that they are going to be, and that's the symbol for perpendicular, opposite reciprocal. So remember, we change the sign and we flip it, okay? If they're intersecting, they're just going to be two different numbers. And if coinciding, that means that they're the exact same line. That means the slope will be the same and the y-intercept will be the same. So you might add both of those, knowing that the slope and intercept will be the same if it coincides. Okay, so remember, in order to determine what the slope is, you must first put it into slope-intercept form, which is y equals mx plus b. So let's take this first equation, our 6x minus 12y equals 24, and let's solve for y and get it into slope-intercept form. Okay, so we would move our 6 over. We would have negative 12y equals negative 6x minus 24. Divide both sides by negative 12. And we would have y equals 1/2 x plus 2. So negative 6 divided by negative 12, those two negatives cancel, make it 1/2, and then we have our positive 2. So that's our first equation. Let's go ahead and take our second equation. 3y equals 2x plus 18. Divide both sides by 3. And so we have y equals 2/3 x plus 6 as our second equation. Now, that's just getting our equations. Now we have to think about our slopes for a minute. So the slope on the first equation is 1/2. The slope on the second equation is 2/3. So the lines are not parallel because the slopes aren't the same. They're not perpendicular because they are not opposite reciprocals. Coinciding's out if their slopes aren't the same. So all we have left to say is that they intersect. And that would be your final answer. Okay, so remember, we're going to solve our equations for y and then go from there. All right, example 2. A couple of things to point out as you're reading through these questions is we're writing in a new equation of a line that is parallel to this equation and goes through point 1, 3. So a couple of things that you need in order to write a new equation. You need to have the correct slope and you need to have a point. Well, we have the point. We need to take the equation 8x minus 2y equals 4, solve for y to get a slope. So let's start there. So step 1, let's take our equation, solve for y, so let's move our 8x over. So negative 2y equals negative 8x plus 4. Divide both sides by negative 2. Y equals 4x minus 2. The only thing we need from that equation is the slope, so that 4. And because it said parallel, we know that the slopes will stay the same. So step 2, we're going to take that parallel slope, which is 4. We're going to take the point that is given, and we're going to plug it in to y equals mx plus b to get our new equation. So let's go y equals mx plus b, just to remind yourself. We're going to take, let me do some highlighting for you. We're going to take our 1, that's our x, so we're going to plug it in there. We're going to take the 3, that's our y, we're going to plug it in there. And we're going to take our slope and plug it in for m. Okay, so we're going to replace and find what our slope, our y-intercept is going to be. So let's make that switch. We could say 3 equals 4 times 1 plus b. So all we did was substitute our 3 values in. Now let's solve. 3 equals 4 times 1 is 4 plus b. Subtract the 4 to get b by itself. So negative 1 equals b. And so that is our y-intercept. So we now have our slope, which is 4, our y-intercept, which is negative 1. And so now we can plug it into our equation. Y equals 4x minus 1. And that line would be parallel to our given equation, and it goes through point 1,3. And so that would be our final answer. Okay, let's try another one. So now we're looking at, all right, so what if I take out a coefficient and replace it with a variable? Can we find that and use our parallel perpendicular tricks with our slopes? So again, we always want to solve our equations for y and get them in slope-intercept form. Another thing that stands out to me as I read this is we want it to be perpendicular, so we're going to have to use our opposite reciprocal slopes. Okay, so step 1. Let's take our first equation. Yes, it has a k, but we can still solve it for y. Okay, let's move our kx over. So we're at 6y equals negative kx plus 6. Divide both sides by 6. Y equals negative k over 6x plus 1. Okay, so this is the slope that we're working with right now. Let's take our second equation and let's solve it for y. So our second equation was negative 3x plus 2y equals 5. Move the 3x over. 2y equals 3x plus 5. Divide both sides by 2. Y equals 3/2 x plus 5/2. Okay, again, we need to worry about the slope because we want them to be perpendicular. But we want it to be perpendicular to the 3/2. So what is the perpendicular slope to 3/2? Would be negative 2/3. Okay, so we're going to take our first slope that we got in step 1. So we would set up and say negative k over 6, and we want it to equal negative 2/3 because we want them to be perpendicular, so we have to use the opposite reciprocal slope. Now you're just solving an equation like we talked about in our algebra review. So we would cross multiply 3 times negative k, which would be negative 3k, equals the other side 6 times negative 2, negative 12. Divide both sides by negative 3, and k would equal 4. So that's what we would need k to be to make those two lines perpendicular if we were to graph them on an equation. So this would be your final answer. Okay, let's keep going. Let's go to example 4. Now we're going to use this graph. So my advice when you're given a graph, and we're going to use the graph on the next 3 equations or problems here. So let's go ahead and find a couple of things so that we don't have to do it every single time. Let's go ahead and find where point A is, point B is, and point C is on the graph. So if we were to count those, point A is at 3, 6. B is at negative 2, 2. Remember, you count your x's first, then your y's. And C is at 5, 0. The other thing that I would advise going ahead and taking care of is the slope of your 3 lines. And so we know the slope of AC. Remember, when we count slope on a graph, we count rise over run. So if we're counting here, we would say it goes down 6, right 2. And so we would say negative 6 over 2, but that reduces to a negative 3. Okay, then we have BC. We know BC's slope is right here, and so we can see that it goes down to right 7. So there is that one. Negative 2 over 7 doesn't reduce, so we'll leave that there. And then the last slope is b to a or a to b, either one. And so BA, the slope is 4/5, doesn't reduce. Okay, so the first one, we are looking at an equation of a line that is perpendicular to AC. So it's got to be perpendicular to AC, so perpendicular slope, and it goes through point B. So you want to have two things every single time. Those two things are your slope and the point given. And so we know the point given is B, -2, 2. The slope for AC is -3, but the perpendicular slope would be 1/3. Okay? Remember, we do the opposite reciprocal. Flip it, change the sign. So that's step one, to always get that part found, your slope and the point that it's going through. So step two is to then plug that in to y equals mx plus b, like we did on example 2. We have our x and our y, and we have our m. So we'll just replace there and say 2 is our y, our m is 1/3, our x is -2, and we're looking for the b, the y-intercept. So let's go ahead and distribute that 1/3, 2 equals, that gives us -2/3 plus b. If you don't want to deal with a fraction, then remember, here's what we do. We multiply by that denominator. So we're going to multiply everything by 3. Not just the 2, not just the fraction, everything. So it becomes 6 equals -2 plus 3b. You have to multiply everything. And now we're just solving an equation for b. Add 2 to both sides. I'm going to move up here and say 8 equals 3b. Divide both sides by 3. And so your b equals 8/3. Leave it as a fraction. No need to worry about decimals right now. Leave it as a fraction. So now, because it's asking for the new equation, we now have our slope. Remember, our slope is 1/3 because we want the perpendicular slope. And our b is going to be 8/3. So we're going to plug that into our slope-intercept form and say y equals 1/3 x plus 8/3. And that is our new equation. Okay, let's look at 5. I'm going to go ahead and copy all of this over. So that we have it. Don't need that. Okay, so now we're looking at an equation of the perpendicular bisector of segment BC. Well, let's talk about perpendicular bisector for a minute. Bisector means that it's cut in half. So if we're thinking about something that cuts a line in half, that would be the midpoint. So we're going to have to think about midpoint in this one. Then we also need to think about perpendicular, which means we're talking about the perpendicular slope of BC. So we want the perpendicular slope of BC. And so BC slope is -2/7, so the perpendicular slope would be 7/2. We flipped it and changed the sign. And then because, again, it says bisector, we've got to find the midpoint. Remember, the midpoint formula is that we add our x's together and divide by 2, add our y's together and divide by 2. And we want the midpoint of BC, so we're going to take those 2 points right here. Okay, so our two x's are -2 and 5, so we would add those two, -2 plus 5 divided by 2. And we would take our y's, 2 plus 0 divided by 2. So -2 plus 5 is 3 divided by 2 is a decimal, so let's leave it as 3/2. 2 plus 0 is 2 divided by 2 gives you 1. So that is our midpoint. So these are all the two things that we're going to be plugging into our y equals mx plus b to find our new equation. Okay, so let's plug those in. Y equals mx plus b. We know our new y is 1. Our m, our slope, is 7/2. Our x is 3/2. And we're looking for the b. So bring your 1 down. We're going to multiply. Remember, when you multiply fractions, you just multiply straight across. So we would say 7 times 3 is 21. 2 times 2 is 4, plus b. Again, if you don't want to deal with a fraction, then multiply by that denominator. So let's multiply everything by 4. And so we would get 4 equals 21 plus 4b. Okay, fraction's gone. So we subtract our 21, and that gives us negative 17 equals 4b. Divide both sides by 4, and so b equals negative 17 over 4. So now I have the two things I need. I have my slope of 7/2, and I now have my y-intercept of negative 17 over 4. So let's write our final equation. Y equals 7/2 x minus 17 over 4. Okay, last one. I'm going to go back here, get all of this so that we have it here. Okay, so last one here. We're writing an equation of a line parallel to BC that goes through point A. So this one, we don't have to do bisectors, midpoints, or anything like that. Parallel means we're bringing the same exact slope. So BC slope is negative 2/7, so we'll bring that down. The point that we're looking to go through is point A at 3,6. And so let's start plugging that into our y equals mx plus b. All right, so y is 6. Our slope is negative 2 over 7. X is 3, and we're looking for the b. Go ahead and multiply negative 2 over 7. Remember, we're just going to multiply the negative 2 and 3, which gives us negative 6 over 7 plus b. Again, let's get rid of our fraction so we don't have to deal with that. Multiply everything by 7. So we have 42 equals negative 6 plus 7b. Add our 6 to both sides. And so we have 48 equals 7b. Divide both sides by 7. And b equals 48 over 7. Leave it as a fraction, see if it will reduce. This one won't. But now we have our b, we have our slope, and so we can plug it in for our final answer. Y equals mx plus b, so negative 2/7 x plus 48 over 7, and that is our final equation. So a couple of things to remember as you're working through this. One, take note if is it asking for parallel or perpendicular. Pay attention to that and figure out what point it wants you to go through. It'll either give you the point, or it might say bisector like example 5 did, and you would have to use the midpoint formula